Okay, P is good morning everyone. So P is we are going to look through question 5 and 6. Okay, in the second video of section B of your 2022 mid-year exam paper. Okay, so let's look at this question. So P is a mixture containing two compounds. Alright, so is after separating P into two compounds, so here's some properties and reaction. So basically a QA question. Okay, so let's look at the filtrate first. So for this, you are looking at warm with sodium hydroxide and aluminium powder. So if you need help with the QA part, okay, you can look at your summary. Okay, under QA. Right, so this one is your nitrate test. Okay, page 43 to 44. 42 is cation. Okay, let me go back. Okay, so basically from page 42 to 44 lah. Okay, for cation anion test. Okay, so this part is for your nitrate ions. Show your nitrate ion. Okay, the second part is you have the other branch. You add aqueous ammonia, white precipitate S, soluble in excess, give a colorless solution. So this part, if you look at your summary, under page 42 is this one, white precipitate. This one, sorry. Okay, white precipitate. Okay, let me scroll up. Sorry. Okay, so your white precipitate dissolve in excess to form colorless solution. So the white precipitate is your zinc hydroxide. Notice actually all the precipitate they are actually all hydroxides on this page. If you realize, hydroxide again. All is actually hydroxide. Okay, if you realize. Okay, let's go back to here. Alright, so this one shows that there's Zn2 plus. Okay, next thing, you have the residue. Okay, warms with dilute hydrochloric acid, you get a colorless gas W. Okay, so this one is lime water. Then you have white precipitate. So this thing is CO2 but revision purposes, the white precipitate is actually calcium carbonate. Alright, once again, going back to the summary notes, you can have a look. So this white precipitate down here. Okay, wait, let me see whether did I write the reaction for this. Oh no. Okay, so basically this is the chemical reaction for the formation of the white precipitate. Right. Okay. Right. Okay, so then you have dilute nitric acid and silver nitrate. That's a test for chloride. Okay, so from here we can identify. Okay, sorry, there is chloride and there's Cu2 plus, because down here you have blue color precipitate. Alright, that is insoluble in excess. Okay, so shows that got Cu2 plus. This blue one is copper 2 hydroxide. In case you want to know. Alright. Okay, then the white precipitate is silver chloride. Right. Okay, so identify Q. Q is zinc nitrate. You can write the name or formula in this case. They never specify. Okay, S is zinc hydroxide, the white precipitate. R is copper 2 carbonate. Because upon adding to acid you get CO2. It's an acid carbonate reaction. R is copper 2 carbonate. Okay, and then T is copper 2 chloride. And U is silver chloride, the white precipitate formed between silver nitrate and copper 2 chloride. And finally W is your carbon dioxide gas. Okay, and what is observed when excess aqueous ammonia is added to blue solution T? Okay, so now instead of sodium hydroxide, you add aqueous ammonia. So in your summary notes, you should have noticed this is copper 2. Soluble in excess to form a blue solution. Okay, so you say that light blue precipitate that is soluble in excess aqueous ammonia to form a blue solution. Okay, right. Then the next thing go on is question 6. That's your speed of reaction question. Okay, so you are told nitric acid added in a flask, excess powdered zinc is added to the acid. Then volume of gas, okay, is collected and measured using a gas syringe. Okay, so 3 marks over here. One for the correct axis label. Okay. 1 mark for correct units on the label. The last mark is for the curve okay, the smooth curve so the curve will look something like this. Okay, then you have volume of hydrogen, or otherwise gas is good enough. This is in time/minutes. Alright, then describe how your graph shows the speed of reaction changes over time. So remember what I discussed, the gradient, use the gradient linked to the speed of the reaction. Okay, break into 3 parts. Okay, initial. Okay, so the 3 parts is what happens initially, then change to gradient, any change to the gradient, and then number 3, end of reaction. Okay, because what you're gonna see is something like this, initially quite steep one, then more gentle, then slowly becomes 0. Alright, okay, so first thing you say is gradient is the largest at start of reaction. So speed of reaction is the highest. Okay, number 2, as a reaction proceed, the gradient decreases, becomes more gentle, or you can say this way. Speed of reaction will decrease. Okay, number 3, and then the gradient becomes 0, so reaction stop at the end. Okay, when all the acid has reacted. Alright, okay. Alright, okay. Then draw on a graph across when the reaction has stopped. So basically here when it becomes horizontal. Okay, then you are told a second set of experiment repeated with the same mass of zinc, but you use strips instead So initially is powder so now strips is anyway it's the excess, so it doesn't affect the volume of hydrogen gas. So the speed of reaction will go down Okay, so supposed to make it more gentle lah. Okay, so I'll draw in orange so something like this. Okay, that's for the graph in I. Okay, right, then you mentioned describe how you use your graph in part A to determine speed of reaction at 3 minutes. Okay, so this one is the at that instance one. You got to mention a couple of things. First is a tangent. Then after that, how you calculate gradient of tangent. Okay. So I say part A. Yeah, let's say you want to draw like this is 3 minutes then you got to draw a gradient, then find its draw a tangent, then find its gradient. Yeah, okay, so what we'll say is this you number one, you have to draw a tangent to graph at 3 minutes. Then number two, calculate gradient by by taking change in volume of divided by change in time. Alright, okay, so this is it. It concludes my second video for section A.